this is the another way and a beautiful way, and which will save so much time. We are going to construct the Lagrangian in another way. All of you please listen, please listen. Now here I have a particle of mass m. If you want to do that, you have to learn something. A particle of mass m. You have done already around 50-60 problems, you already done. All those problems we can do by using this method within 1 minute, within 1 minute. How? Ready. Whenever you consider the particle, that particle in motion, how many types of motions you have seen? Two. One is a translation, another is a rotation. Other than this, anything is there? Translation plus rotation is there. That is called rolling. Okay. Now every particle is having two types of motions. One is translational, another is rotational. Okay, so for example, here is a mass m which is moving with some velocity. Then could you please tell me what is the kinetic energy? If it is a linear, we can take a V equal to either x dot, r dot, something, whatever it is. Can you please tell me how much it is? Half m x dot square. Super. Now another motion, for example, this is the origin O, center, and with respect to this, this body, this particle is making a circular motion. Sir, rotation or circular? Both are same. Every rotational motion is a circular motion, every circular motion is a rotational motion. Every rotational motion is a circular motion. Circular motion is a rotational motion, but every rotational motion need not to be a circular motion. Sure. What is the difference? Radius, r side. Now let us suppose this is L and this is the mass m. I told you already. Whenever the body is moving in rotational motion or here circular motion, could you please tell me what is the velocity it is having? What velocity that particle is having in a circular motion? Tangential velocity. Tangential velocity. The tangential velocity is always equal to, if I assume this is the angle theta, now here omega is nothing but theta dot. What is the radius? That's why V equal to. That's good. So these are the two different velocities we have. Okay. So what are the possibilities? What are the possibilities? Ma, observe carefully. These are not in the books. What are the possibilities? The particle may have two translational velocities, or two rotational velocities, or one translational, super, one translational and one rotational. Sir, no sir, we didn't get an idea of how it is. Translational. For example, take a wedge, okay? Take this wedge. For example, take this wedge. And now this is a block of mass m, which is sliding like this. Sliding like this. And it is moving linearly along this path. And the entire wedge is also moving. Then how many translations this mass is having? That's good. One is along the plane, another is along x-axis. Say yes or no? Yes, sir. Next, two rotational. In last class you have seen there is a ring. A bead of mass is moving on the circumference of the ring, and the entire ring is rotating like this, and a bead is rotating like this. How many rotations it is having? And the next, one translational and one rotational. You have seen a rod, a bead of mass is sliding. Sliding means what? Translational. And that rod is rotating like this. What is that? Rotation. Clear, ma? Cool. So here what I am assuming is these are two translational velocities. I will take V1 and V2. Here also V1 and V2. Here also V1 and V2. Okay. But I want one thing, kinetic energy. Everybody know what is the kinetic energy of the body. Kinetic energy of the body T equal to half mv square. But your particle is having many velocities. Then how to get the resultant velocity? I hope everybody know from the intermediate. This is the V1, this is the V2, and the angle between them is theta, and this is the resultant. Can you please tell me what is the resultant? V square equal to, very few people are saying, remaining people what happened? Come on, everybody say. Some people are waiting till some other people say. That means you don't have confidence. When you will get confidence, if you are keep on saying, you will get. Again! V1 square plus V2 square plus 2V1 V2 cos theta. That's good. Now, let me take a few options. If I assume the angle between them is 90 degrees, then cos theta term gone. Then could you please tell me what is a V square? V1 square plus V2 square. And sometimes theta equal to 0 degrees, then V equal to 0 degrees means V1 square plus V2 square plus 2, then V equal to next theta equal to 180 anti-parallel, then V equal to, that's it. A few examples. Okay. So if it is some general theta, what is the resultant between two velocities? V1 square plus V2 square. Remember, with this method, we can find the resultant velocity between only two, because vector algebra will give you the resultant velocities between how many? 2 or 3? If more than 2, then what you will do? If more than 2 vectors are there, how you will find the resultant? What is matter note 10 sara ni tum padega vector మీరందరూ బ్రిడ్జ్ కోర్స్ చూసినట్టయితే ఆ వెక్టర్ ఆల్జీబ్రాలో ఎక్స్ప్లెయిన్డ్ దట్ resolution of vectors. If 3 vectors are there, we have to resolve each and every vector, add all I components, add all j components, then something I cap plus something j cap. If 2 vectors are there, directly you can use this formula. If 3 or 4 vectors are there, add 2, it's not like that, be careful. Okay, what you have to do? Resolve and add all I components and add all j components, then something I cap plus something j cap, then what is the magnitude? Under root. Cool, that's good. And this is the method we are going to apply here. All of you please listen. Very simple, amma. What I am saying is, there are only 2 velocities. One is that everybody know, another is or circular. What is the rotational velocity? V equal to always V equal to r omega. Please don't forget. And these are the possibilities we have. Maybe 2 translational, 2 rotational, or 1 translational, 1 rotational. Anyhow, if you have a single velocity, then there is no problem. If you have more than 1 velocity, then we have to find the resultant by using the formula V square equal to super. Let me start. Now first one, I am starting with a simple pendulum. This is the mass m, this is L and theta. Now carefully observe in my method how the body is moving. Like that you have to act. The body m is moving like this. So draw a line like that. Super. Now one thing is very clear, it is in a circular motion. Everybody know what is the circular motion velocity? V equal to, what is R? What is omega? V equal to, that's it. Single velocity or multiple velocities, sir? Kinetic energy equal to half m. See, we are not writing many steps. Next one, I have to find the potential energy. This is my y-axis, L theta. How much? Good. The potential energy, shall I write directly? Come on, say. From this, I request you, please write the Lagrangian. I am not writing here, there is no space, that's why you please write. Okay, na? Right. You please write. Okay, I will write. Yada teacher, tada students. Minus of minus plus mgl cos theta. Next, second one. I am taking spring pendulum. See how quickly we are doing. Please observe. Please observe. It's a beautiful method. Please learn. Now here I have an angle theta and the original length is L, extension is R. Now please observe how the body is moving. Please observe. The mass m is moving like this. Say yes or no? That's why, is it tangential velocity? Yes, could you please tell me what is the tangential velocity? Super. L plus R. Good. Shall I take it as a V1? Anything you can take, let it be V now. And observe one more thing. This is the spring. So you attach it to the spring. That's why the mass will come down and again up like this. Now just draw the arrow mark. If it is a circular, take a tangent. If it is a linear, in that arrow mark. Clear? Now, and what is the displacement here? L plus R. It's a differentiation. Velocity V equal to L dot constant. Okay, ma. Now, what is the angle between these two velocities? Shall I take it as V1? Shall I take this as V2? What is the angle between these two? How do you know? Radial. This is the tangential and this is the radial. Both are at 90 degrees. Very good. Sit down. If 90 degrees, could you please tell me what is the resultant? See, I have not written any coordinates. I have not differentiated nothing. What is the resultant velocity? First say the formula, ma. V1, V2, angle theta. What is the resultant V square?
V1 square plus V2 square plus 2 V1 V2 cos theta.
Now theta.
Cos theta, cos 90 is 1. Sorry.
Even 10th class student కూడా చెప్పడేమో wrong.
0 plus, so V1 square plus V2 square.
That's it. V1 square plus V2 square. Sit down. 2 V1 V2 cos theta. Here cos theta is what? 0. That's why V square equal to V1 square V2 square over. You can say it's a plane polar coordinates, I will write. But not all problems, na. That's why develop a method, common method for all the problems. See, all problems won't be plane polar, na. Something different also he can frame. That's why develop a method. What is our method if you are observing? How the particle is moving, we are observing. If it is a translational, we are striking a line and that velocity. If it is a circular motion, we are striking a line tangential. And after that, we are checking what is the angle between them. If theta is the angle, resultant velocity equal to V1 square plus V2 square plus 2 V1 V2 cos theta. So you got the kinetic energy. I hope I need not to say about this. Could you please tell me? Minus L plus R cos t. Can you write the potential energy?
Yes, sir.
Write the concept, but don't copy the problems. Diagrams also you know. Please do it yourself. You will get confidence. It's an intermediate, nothing else. Just I have used the intermediate concept, plus 2 concept, 10 plus 2 level. Please write the potential energy and write the Lagrangian also. No need to copy, you can do it yourself. Be confident, you can do it yourself. So just we have taken combination of translational, rotational. 2 translational, 2 rotational, or 1 translational, 1 rotational. Other than that, there will be no other option. So let it be V1 and V2, and the resultant is V1 square plus V2 square plus 2 V1 V2 cos theta. Only 2 motions, one is the translational, another is rotational. Just please focus on the concept. It's a competitive exam, so we have to finish the problem early. That's the aim. We are not using the method described in the books. Just we are taking the velocities and finding the resultant. Right. Now let me explain this also, all of you please. Now here you have two masses. Earlier problem there is only one mass, and here two masses are there. One is a capital M, another is a small m. I request you please, is completed or not? Not completed. Do it, make it fast. Speed, maintain the speed. Right. Now listen. I request you, please observe the diagram. Listen. See, I am explaining what I am explaining, how to handle the problem. If you listen carefully, the same idea you have to apply to the next problems. So that's why please listen carefully. Now observe the diagram. How many masses are there? Two masses. One is a capital M, another is a small m. Then how they are moving? Capital M is moving like this. That's why like this. Its velocity equal to displacement x. That's why over. Okay, carefully observe. And now, is there any other velocity for capital M? That's why its kinetic energy equal to half capital M x dot square. Say the answer confidently, please. Otherwise, when you see a question in the exam, final exam, you won't have guts to attempt that. First, you have to get that confidence. Right. Next, small m. How small m is moving? Observe. Is it moving like this? Okay. That's why. What velocity ma? Super. This is theta, this is L. How much? Everybody try to say L. Good. But this small m is attached to capital M. That capital M is moving forward. That means I am moving forward means my hand is also moving forward now. Why? It is attached to me. So simple reason. So that's why this m is also moving forward with velocity. Now you have to learn something from 6th class. Two parallel lines are there, one transversal. Okay. What are these angles called? Alternate interior angles. 2-3 days onwards I am teaching to my son these things. Okay. So alternate interior angles. This is a 1 and 2. Similarly 3 and 4. All these interior angles 1 and 2 are same, 3 and 4 are same. Okay na? Next, anybody knows what is this and this? Correspondence angles. Anybody knows what are these two angles? Linear pair. Whose sum equal to 180. Okay, anyhow, here we want alternate angles. Now see, I hope everybody know. Alternate angles are same. Yes, correspondence angles are same. Yes, vertex angles also same. Vertex angles means angles at a vertex. These two are same. I hope you remembered from your 6th class. Now see, this is one line and this is one line. You have to assume like that. Is it a transversal? Okay, wait a minute. Oh, that I am not taking that, sorry. Okay. Now see, this is a dotted line, see everyone? Are you observing the dotted line? Yes, now I am drawing one vertical line like this. Now see, this dotted line and yellow line both are. This is transversal. నోరు పేరు చదవటానికి కూడా రావట్లా. ట్రాన్స్వర్సల్. Then if this is the angle theta, could you please tell me, is it alternate angle? That's why this is also super, but we don't want that. If this is theta, this is, if this is 90 minus theta, this is, got it? One more time. Everybody got this is theta. Once you got this theta, radial and tangential 90 degrees. That's why this one, once you got this 90 minus theta, vertical and horizontal, 90 minus theta, this is, that's it. Now small m is having two velocities. One is x dot, another is L theta dot. What is the angle between them? Super. Could you please tell me what is the resultant velocity? Why you are slowing down? Come on. That's it. Now kinetic energy equal to half m x dot square plus L square theta dot square plus 2L x dot theta dot cos theta. That's it. And the potential energy, no potential energy for capital M, small m only. This is L and this is theta. How much? Super. Minus mgl cos theta. Now the Lagrangian equal to half capital M x dot square plus a half small m x dot square plus L square theta. So here I am explaining on the board, that's why these many types, these many steps I am writing. Once you understand, you need not to write all these steps. Directly you will write velocity x dot, kinetic energy term you will write, and you will get v square, and both you will add half capital M x dot square plus half small m v square, and the potential energy is minus mgl cos theta. That's it. Are you understanding? Yes. Okay. Come on, start. Don't copy. Please do it yourself. Please do it yourself. Because if you learn this method, it's very helpful for you. Please. You have to observe the motion and take the particle m and represent the velocity. See, I have taken m again, it's moving horizontally and it is having a tangential speed. Again I represented the diagram, then it is very easy to understand. So theta is the angle, take your time, but don't copy from the board and understand and do it yourself. You should learn, that's it. Try the next one yourself. Those who have completed third, try yourself. Please observe how the particle is moving. Take m again, my advice. Take m again and represent the velocities and take the angle between them. Just to represent the velocities and take the angle between them. How simple it is. Come on, come on. Please take m again and represent the velocities for that mass and take the angle and try yourself. If you are facing trouble, I will explain. I think only you are writing 2 or 3 steps. Please learn the method. If you see a running race, the winner won't spend more energy at the starting. I don't know how many of you know this. The winner spend more energy at the end of the race. So at the end of the coaching, who are spending more time? Those are the winners. Beginning, it's not a problem. But till the end, who will carry? That's most important. You should not stop till you get the success. Exam ante some people just like a time pass, just 1 hour, 2 hours revising the notebook and leaving. How you will get? For us to prepare the paper itself, it takes 5 hours, 6 hours to upload, to spend, 5 hours we will spend with the paper. Please try yourself. My advice, take the mass again and represent the velocities with that mass, how it is moving. See, still if anybody is not getting idea, this m is a sliding. Babu, see, I have taken mass again, m is a sliding like this, because in the diagram you will get a confusion. Only represent velocity. Displacement, velocity. Next, how it is moving. Mass is moving like this or like this? Like this. Am I right? That's why. Is it? How it is moving? Just to draw the line. Now it's a circular motion. That's why tangential. What is the tangential velocity? V equal to, what is the radius? Angle. That's it. Theta dot velocity. What is the angle between these two? Over. Now come on, say V square equal to over. Come on, come on, come on. Be confident. Find the potential. So this is the height, r sine theta, positive height, mg r sine theta. Directly write. Now write the Lagrangian. Now please take the mass like this and represent how it is moving. You try yourself how the mass is moving like this. That's why this is r dot. Next one, how it is moving. Draw a circle. Draw a circle and there take a tangent. See, maybe if you are facing trouble. Amma listen. This is the m sliding like that. That's why I have taken r dot. Now this m is moving in a circular path or not? Yes, this is the circle. See, m is moving like this. Just I have drawn a circle like this. Ma, only two motions, ma, please believe me. Either translational or rotational or both. That's it. Now circular. What is the velocity? Tangential. Tangential. But what is the radius of the circle? Radius of the circle. Very few people are saying. Sine alpha. What is the omega? Omega. What is this velocity? V equal to r omega. What is the radius? That's it. Ma, one is like this, another is like this. What is the angle between these two? This is radial antarandi. What is this? Radial. This is what? Tangential. What is the angle? Come on, come on. If I say like this, you won't get idea. You have to try yourself. Once you understand the method, it's very easy to handle these Lagrangians. You will enjoy. Any problem we can do within few minutes. Next, potential energy. This is R, this is alpha, this is R cos alpha. Just take the mass again and how it is moving, draw the diagram, then you will understand. My humble request, take the mass again, take the m again and represent how it is moving. Dotted lines you can draw. ఏం డౌట్ ఏంటి బాబు అంటే మీరు అబ్జర్వ్ జస్ట్ ఇఫ్ యూ అబ్జర్వ్ హౌ ద మాస్ ఈజ్ మూవింగ్ ఐఎమ్ రిప్రజెంటింగ్ హియర్ మాస్ ఈజ్ కమింగ్ డౌన్వర్డ్ మాస్ ఈజ్ మూవింగ్ లైక్ దిస్ దట్స్ ఎ లైన్ ఫర్ దట్ టాంజెన్షియల్ బికాస్ ఇట్ ఇస్ సర్క్యులర్ దట్స్ ఇట్ యాంగిల్ ఈజ్ 90 degrees. Once you understand how it is moving, this job is over. Please take the mass separately. Then represent how it is moving. M is moving like this. Please draw dotted lines. Nothing will happen. You know how it is moving. In a circle like this. And the entire thing is rotating. That's why M is rotating like a horizontal circle also. That's it. If you draw these two circles, it's over. One circle in the horizontal plane, one circle in the vertical plane. Now both tangentials take. Tell me what is the angle between vertical tangent and horizontal tangent of the circle. Why? Vertical and horizontal plane 90 degrees. That's it. This is the horizontal plane and this is the vertical plane. A vector in the horizontal plane, a vector in the vertical plane, angle 90 degrees. Both are tangents. Tangent, tangent. Yellow circle radius r, omega theta dot. Are you doing? Red circle. What is the radius check? How much? R sin theta. What is the omega? Omega. So that's why velocity r sin theta omega. Amma, horizontal plane, vertical plane, angle 90. You will forget, please write down. This is in the horizontal plane. After going back to the home, you will forget again. And this is the vertical plane. Horizontal plane and vertical plane, two tangents, angle 90 degrees. Now get the velocity v square and kinetic energy and potential energy. Maximum 3 steps. If you see carefully, now you have done these 6 questions or 7 questions. Out of this you have done one day some questions, another day another questions. But now all the things you are doing now itself. Come on, come on, be confident. If you represent like this, you won't face any trouble. Understand the diagram and act like a particle. Means how it is moving, just act. Then you will get the diagram again and take the velocities and angle. V square equal to r square theta dot square plus r square sin square theta omega square. That's it. Potential energy downward, that's why minus r cos theta. Don't copy, don't copy. Answer minus mgr cos theta. Now the Lagrangian. Babu, please learn, Babu, you will enjoy, please learn. If you see the books, they will write so many steps, but we are writing 3 steps. At least after doing few problems, you have to get an idea. If you are copying everything, no use. Abba, red shirt, white girls. Nothing is there, Babu. Just how it is moving, draw that lines. And circle, take tangent. If line, linear, take a line and take the angle between them, you will get the answer. Right. I will explain this double pendulum. Everyone, please listen. If you see these books, they will solve this within 1 page, I think, around. But we are ready with the 3 steps. Ready. So first, let me draw the diagram. Now let us say M1 or M2, anything you, sorry, M or M. No, if I have written M means both same masses, otherwise M1. And this is L1 and this is theta 1. And another pendulum. Everyone please observe, please observe. If you listen carefully, you will understand. Otherwise, మనిషి ఒక చోట మనసు ఒక చోట ఉంటే కష్టం. Now you have to act. How it is moving, you have to act like that. Okay. Now this is M1. This is the fixed point. So my M1 is moving like this. Yes or no? Let me draw that. Over. Now is a circular or a translational? That's why tangential. So what is the radius? Very good, very good. Say properly. Good, good. Next, forget about M1. Now M2 is attached to M1. Forget M1. This is the point of suspension for M2. Ayo, again M2 is also moving like this. Okay. Again circle. What is the circle? Tangential velocity. Again draw the tangent. Amma, everybody know how to draw the tangent? ఇది సర్కిల్ అనుకో, ఇది ట్రాంజెంట్ కాదు. Right. So this is what? L2 theta 2. But this M2 is attached to M1. Whatever the velocity of M1 will be transferred to M2 as it is. How much? Everything is fine, but the most typical part is you have to find the angle between them. How to get the angle between them? I will tell you one thing. For example, I said my velocity is x dot. What is my displacement? X. Yes or no? Then along x axis what is angle? 0. I said my velocity is y dot. What is my displacement? Y. What is the angle between the x axis and y axis? 0 no. X axis 0 ante y axis 90. So whenever tangential velocity is there, observe carefully. This is the tangential velocity. Two velocities are there. One is L2 theta 2 dot. What is the meaning of x dot? X dot means my displacement is changing along which direction? X direction. What is theta 2 dot? Theta 2 direction. This one. What is the difference? That's it. Angle difference. This is velocity changing along theta 2. Theta 2 is changing. That's why you got theta 2 dot. Here, that's why you got theta 1 dot. Or else you write like this. What is changing? What is changing? What is the difference between the changes? Your wish. Theta 2 minus theta 1 you can take, or theta 1 minus theta 2 you can take. Why sir? Cos. That's why over, see? Ready? M1, it's over already. M1, only one kinetic energy. Come on, say. Now, I am writing for M2, kinetic energy. M2, two velocities are there. Could you please tell me what is the resultant V square? Come on, start. If you just go back and see your notebooks, how much struggle you have done there. So you differentiated, square and add, and after that you have done lot of difficult algebra. So this is 2 L1 L2 theta 1 dot theta 2 dot. That's it. I hope everybody will write this. Next, wait. I have to find the potential energy of first mass. This is the first mass. So let us suppose first mass depth is a h1, okay, and second mass depth from this point, how much? I want to ask one thing. While you are finding potential energy for M1, what you will consider? M1 G H1. While you are finding the potential energy of M2, what you will consider? M2G. That's it. Everybody understand? So I hope everybody know what is H1. This is the origin. Come on. And H2. See how simple it is. M1G H1. If you are having a trouble, sir, I will forget again, then write like this. Minus M1G L1 cos theta 1. I am writing V2 M2G H1 plus H2. Just substitute H1 H2. Don't get a tension. Both minus M2G, come on, L1 cos theta 1 plus L2 cos theta. Don't copy. If you are copying means you didn't understand and you don't have confidence on you. Theta? Theta 2 changing like this because this is the theta, increasing theta 2. Theta 2 is increasing in this direction, this much increase. L2 theta 2 dot means theta 2 changes, that's why you got theta 2. L1 theta 1 dot means what changes? 1 changes. What is the difference between both the changes? That's it. That's it. Nothing else. We have to get the angle between these two. This is going in the increasing direction of theta 2. This is going in the increasing direction of theta 1. What is the angle? What is the difference between them? Theta 2 minus theta 1. Theta 1 minus theta 2. Anything you can take. It's not a problem. See, if I write x dot, what is the meaning of x dot? I am moving along x, changing, x is changing. If I write y dot, what is the meaning of that? Y is changing, that means the displacement is changing in the increasing direction of y. If it is a decreasing in the opposite direction means what? We will write minus y dot. I have written plus y dot. What is the meaning of plus y dot? Positive y direction, increasing direction. Got it? Similarly, theta 2 dot means it is changing in the increasing direction of theta 2. This is changing in the increasing direction of theta 1. Then how much difference is there means theta, how much difference in the increase? Theta 2 minus theta 1. That's it.